Okay, so what else can trig ratios do? Trig ratios have the power to let us find the angles based on the trig ratio. So they're very, very powerful. So find the measures of E and F. Now there are multiple ways to do this. So let's start with E. Based on what I'm given, which in relation to E, I'm given the hypotenuse and I'm given the side adjacent to E. So adjacent and hypotenuse, I'm talking about the cosine of E being equal to 12 over 13. Now, if I'm asking you for the trig ratios, that would be your answer. But I'm asking you this time for the angle measure. So I basically have to undo the ratio to get the angle out. And the way I do that is I'm going to take the inverse of the ratio. Now, this is not a -1 power. If you go to your calculator, right above the sine, cosine, and tangent buttons, there is a sine -1, cosine -1, and tangent -1 button. Those are the inverses. So what you do, and again, this is different for different calculators, but this particular calculator, I would do second and then cosine, because I need the inverse, see the -1, enter that fraction. You can either use a fraction or a division bar. Be very careful with the parentheses and hit enter. And the angle measure is 22.6. 22.6 degrees. So I undid the ratio to get the angle out. Every angle with the ratio of 12 to 13, which could also be 24 to 26, which could also be 36 to 39, is going to have an angle of 22.6. That is how trig ratios work. So what about F? F, okay, so in relation to F, I know the side opposite and the hypotenuse. And so I'm going to do the sine of F is equal to 12 over 13. So when I go to my calculator and I do the inverse of 12 over 13, but this time with the sine ratio, I'm going to get a different angle. So second function, sine 12 divided by 13, close the parentheses, and I get 67.4. And so F is equal to 67.4. If you add 67.4 and 22.6 and 90, you should get 180 degrees. So you should know that you have the right answers. So let's look at two more examples. J and K. J. What sides do I know in relation to J? Well, I know the opposite and the hypotenuse. So I'm talking about the sine of J being equal to 9 over 11. To find J, I do that inverse. There's no way to do this except with your calculator. Go to your calculator. Second function, sine of 9 over 11. And, whoops, second function, sine of 9 over 11. Heavy finger on the calculator. One more try. Inverse 9 divided by 11 is 54.9. No, I knew that 0.01 wasn't correct because an angle shouldn't be that small. It doesn't make sense. So I know that J is equal to, what did I say? 54.9. 54.9. Now, what do I know about K? Well, K is adjacent and hypotenuse. So I'm talking about the cosine of K is 9 over 11. And so K will be equal to that inverse function of 9 over 11. So I'll go back to your calculator. Second function cosine, 9 divided by 11. And I have 35.1. And k equals 35.1 degrees. And that is the real power of trig ratios, is to be able to find angles if I know the side lengths. So the measure of g if the cosine is 0.53. This is another way to look at this. This is a ratio, a fraction that's been moved out into a decimal. So again, I am just going to take the cosine inverse with my calculator. And if you do that, second function cosine of 0.53, you get 58 degrees essentially. If I go to a tangent, my next one asks me about the tangent of v. Tangent also has an inverse. The tangent of 2.25, that is 66 degrees. 66.04. And if I'm talking about the sine, second function sine of 0.978, then I'm talking about a 78-degree angle. Now, if you want to check your answer, you can quickly check your answer by saying the sine of 78 degrees, and your decimal answer here better be close to what you inputted. And that is how you can check your answer very quickly also. Now, our word problems certainly aren't going to go away. So a 5-meter long ladder leans against a wall with the top of the ladder being 4 meters above the ground. What is the angle the ladder makes with the ground? And we use a couple of Greek letters for angles. We use theta and sometimes we use alpha. They're just other ways to notate the angles. It's not a big deal. Based on this, I know opposite and hypotenuse. And so I'm talking about the sine of theta being 4/5. Go to your calculator and do the inverse of 4/5. And when you do that, you find out that theta is 53.1 degrees. If you look at this next example, very similar example, except our ladder this time is 12. It is resting up 10. What angle does it make with the ground? Again, we are still talking about opposite and hypotenuse. So we're talking about the sine of alpha is 10/12. When I take the inverse in my calculator of 10/12, I'm talking about a 56.4 degree angle. It seems like a lot of information, but it's really about using your calculator. So make sure that your calculator will behave like I said it would. Just as a quick note, if you have the other types of calculators, you can see that your sine, cosine, and tangents are here. The second function button will give you your inverses. Here are your sine, cosine, and tangents. Here's your inverses to get these up here. With both of these, you need to enter your number first. So you need to type 63, then hit cosine to get the decimal ratio. Or you would hit your 0.35 second cosine to do the inverse to get the angle out. So play with your calculator and make sure that you can make it work appropriately. Another thing I recommend is in the examples like where you have 15 cosine 33, I would always calculate this first, hit 33 cosine, and then I would hit equals, you're going to get a number, times 15, and then I would hit equals, and you will get your number. And then if there's a division problem that comes after, then hit divide. But do them in pieces or be safe, figure this decimal, write it down, then take it times 15. You don't want to make a silly calculator error because you told your calculator to do the wrong thing. If you have questions on this lesson, please post them. I will try to maybe get some notes or an extra video recorded before class tomorrow if we need it, or get a message to the substitute to clarify things for you. Good luck with your homework.